Hi, we have the TS-50 back on the bench. I wanted to see if I could get around to trying to finish this one up. I've been very busy here in the shop and at work, and only getting about one day a week to get in here and work. So it's Friday evening and it's snowing outside, so I thought I'd put this on the bench and take a look at it. The last we seen that we had put the board in that Grant sent, and we do have the radio receiving. There is some noise in it, but it's not completely clear as it should be. So we'll have to look into that and see what's causing that issue. So I wanted to show you my biggest concern with the radio now. I've switched over to the dummy load, and we'll go up. No, excuse me, we'll go down. I'll set it for about 14,250. Onto the dummy load, and we'll key the mic. You see the on air light comes on, and there's no power out at all. Nothing. And we'll verify that the TRXBench board is working. Inside here behind this coil is a little small LED. Second, we focus down on that, and you see the LED is coming on, which means the TX board is going into transmit mode. Okay, so now it's Saturday morning. Yesterday I was going to perform a few tests, and I went up to the IFR and I set it for spectrum, and as you see, there's no display in spectrum mode, although scope mode is working, but spectrum has completely gone. If I turn it over to very minimum intensity up, turn the vertical up, I can barely see a little flash in there. It's hard to see with the light on it. So this has happened before, and this time I think it's a different problem. I've noticed that I'm even in scope mode, I'm having to turn the intensity all the way open. As you can see, when I get about 2 o'clock position and start going down to 1 and 12, the trace just disappears. So if I run it all the way to the top, this should bring the noise floor up higher, and go to it. I can barely see some flashing in there. So looks like I have some high voltage problems in this thing again. So that's okay. We can do this test a different way. I just won't use a spectrum on it. So basically what we want to do, we want to verify that we do have signal coming out of the TX board. If we look at CN13, this goes to the final unit, and it says drive beside it. It comes through, goes through this coil, L55, through this amp, and then on over here through some switching circuits. It goes through all these switching circuits for the different bands, and you can see it comes here. It goes through L51. Let me slide this over just a little bit, and then it comes through your mixer. This is your transmit mixer section. So we can check back to here and see if we're getting any single coming out, and that's what I was going to use the Spectrum for, is just tie right to the antenna port, because that'll read a very low 1/4 watt single. So we'll have to do this a different way, see what can come up. We got a lot of voltages that I can test. Out of the mixer we should have like 2.1 volts on transmit. We'll check through that and see what we find. So here on the back side of the board I have CN19 here, and that's for the drive, and this goes through L55 and then through this transistor on the back side of the board, and then through these little boards here, and then on into the mixer system. So I just coupled a coax jumper into the drive, removed the connector going to the final, and we got that right into the oscilloscope, and we'll key it up and see if there's any signal there at all. And I'm seeing nothing. Nothing at all. We're AC coupled, so if there's a signal there, we should be able to see it. We'll go to DC couple. Set this right to center. And as you see, for a brief minute, it goes. It's sensing a switch, but it's still showing no DC voltage there. And we should have about like somewhere between 700 to 800 millivolts off that port, according to the schematic. So I found something a little interesting then. I went to measure this voltage off of L54, since we can get to that. That's on the top side, and it's tied to the collector of Q50, which is the amp. And I was going to check for my 13 volts, 13.1 volt on receive, and around 850 millivolts on transmit. And I was looking at the scope also, and I was probing with the digital voltmeter, and I noticed that I saw a single come up on the scope, and I touched this coil, and when I touched that coil, the single would come up a little. So something funny going on in this coil right here. So let's have a look at this coil and see what we can see. So just you can see, this is L55 here, and we got several similar coils around over here in the mixer section, and the coils are mounted in a little plastic former, and it's slit, the coil set inside of it. When we look at this coil, we can see that one side is broken off, and the coil is very loose. So let's get the microscope on that and see what we can see. Okay, so now you can see the back side of that coil. And I'm working it just a little bit. Get a small pointer. You can see, I can barely see it right there. Right there. There's a green wire that has broken off from the coil. And this is due to the little holder is gone. So that made the coil loose and it's broken the wire off. So that would definitely cause it not to pass much signal to go to the output. So I think what we'll do is replace this coil. And I have another board, the old original board that was in here. So we'll look at that coil, make sure it's okay. And we'll pull this board out and replace that. I decided to look at the other coils since we were already doing that. And I found this coil right here. That's L51 that's just on the outside of the mixer. And you can see it's loose also. And one side of the form was broken. And when I put the microscope on it, I was really surprised. So looking at L51 under the microscope, see that the wire that was here is gone. The wire coming up from here is gone. They've all broken off. And this is just after the mixer section. So we might as well replace that one also. Now we could, you think hard to do, we could sit down and get us 3 small pieces of wire and rewind this. But there's no need of doing that since I already have some. And I just looked at them and they look okay. You know, in my last video I was talking about using your senses to find problems. It's great to have test gear. I love test gear. I love vintage test gear. I love any kind of test gear. I don't have a lot of modern test gear. I'd love to have a new spectrum analyzer, but you know, I make do with what I got. So now I got to repair that again. But a lot of times just looking around you can find these things that are obvious, you know. And just another example of it, if I would have inspected this board a little bit closer when I first put it in, I probably would have seen that, but I didn't, which that left for another video to make anyway. So we're going to get the board out, remove those 2 coils, pop 2 more in, and see where we stand at. Before I got into removing this coil, I just wanted to show you what we got to deal with. See right there is the green wire that's coming down, and you can see where the plastic is broken. It's supposed to be a former that goes all the way up, and it's gone. There's the part of the green wire which broke off from. Now I probably could go in there and scratch this coating off and reattach these 2 wires, but I don't know what kind of shape the rest of the wires are in, since this thing has just been loose and flapping around in the breeze. So I'd rather just replace the whole coil, although a lot of caution is going to be needed. You see, these are the pins that's going through the boards, and there's solder on both sides. I'm pretty sure there's a via in there, so we'll have to be very careful when removing this. Probably could go on the other side and use hot air and heat the whole thing, but you got to remember though, there's SMD components on the bottom side, and chances of them flying off, there's too many of them to try to cover up with heat resistant tape. So you really got to take a lot of care in this. Another thing, you don't want to keep the pins too hot, because they'll melt out of their plastic holder and come unsoldered and pull out, and then we'll have the same problem again. So it's just going to take a lot of care to get these things out of there, especially the good one. So it's going to be fun, but we'll see what we can do. So as you can see, we got L55 out, and the way I did this was before I removed it, I applied fresh solder to the 5 pins, because the old solder is just old, it's crusty, you know, it's contaminated. I put a little flux on it and applied fresh solder to it, and then I used my old solder sucker, it's you know, a powered solder sucker, to suck the solder out. And this pretty much got the solder out of both sides of the board. The thing is, you got to keep the temperature down a little bit, that way the heat flows all the way to the other side, and then suck the solder out, and that cools the part back off. And then after I did that, I just take my hot air and heat it just a little bit, the core fell right out. So that made it pretty easy and no damage to the circuit board. And there's the shot of the component side of the board. You see all the traces and the vias are still in place, so no problems there. It came right out without a problem. So, you know, just having the right tools, even if they are some old tools, helps a whole lot at doing this. If you just try to heat it from another side and pull it out, you're going to pull the pins out of the part, or you're going to pull the via out of the board. Then you're going to end up with a bad trace or missing trace. And here we can see the core that I'm removed, and it starts off here. You can see there's 3 wires wound together. There's the green wire right on the edge going to this outer pin, and it goes around. All 3 wires are twisted together, and it goes around 8 turns, and then on the other side where it's broken at. So the green wire is supposed to come out and come over to this edge of the pin here. As you can see, it's broken right next to it. I tried to pull it out a little bit to see if I could get it soldered, but these wires, they have coated them, so it won't able to do without, you know, unsoldering everything and pulling it out. So replacing here is probably the best option. Okay, I got L55 and L51 replaced, and like I said, all I did was just put a little flux, flow some fresh solder on the back of the cores, stick it in the panel vise, and then use my old antique vacuum solder pump right here to suck out what was in there. So it's L55 and L51. So we'll get this mounted back in the radio and we'll do some tests and see what we got. Okay, we got the board reinstalled and everything connected up. 14.250 on FM, and got it hooked to the scope. And let's see if we see any signal out of this whatsoever. Oh, we have RF. Now, using the scope, we don't know where the RF signal is. So even though our spectrum analyzer is not working, we can still use our RFI, or RF, excuse me, to see if we got any signal. I've got the monitor set to 14250 FM, frequency error on 3 kilohertz, and we'll turn the volume up. I'll break the squelch. So we set, key up the radio. I am showing some signal, but frequency on 1 kilohertz. Test 1 2. Test 1 2. Test 1 2. So now the radio is putting out a carrier. And I don't know if you can see it, but the spectrum is trying to come back to life. Radio test 1 2. 1 2 test. So we now have carrier out of our transmitter. So I'll reconnect the cable going to the final back into the drive port, and we'll check and see if we get any power output out of the radio. Okay, I got that connected up, and we're not getting no power at all out of the radio. Nothing at all. So, you know, there could be several things that's causing this. The power amp might not be switching in. It's possible there's a problem in the ALC circuit, just like the one Peter was working on. That could be cutting it back and not letting no power at all out. This ribbon cable here is a little crusty. So what I'm going to have to do is remove the filter board and go in and check to see if we're getting any switching on the PA board, and see if it's even trying to come in. And we'll get that pulled out, and then we'll come back and we'll look at this and see what's going on with it. So go figure, now the spectrum analyzer has gone back to work. Oh well, I'll have to tear in that thing one day, but that'll be another video. Back to the radio. So I started just looking through the service manual and then the schematic. I'm looking at different singles, and I got CN1 here that goes to the filter board, and I go to TP3 and I don't have any single at all coming through that relay. So as you can see, here's CN1. That's the little port on the board where it goes to the filter unit. We trace back and we have the relay here, which is K1. And right here is a 470 ohm resistor labeled R2. And this is TP3. And I can get some single on one side, but I'm not getting nothing on the other side. I don't know if this relay is shorted or if there's something going on in this area. So I'm going to pull the board back out, because all these components are, most of them are on the back side of the board, and we'll have a look at it. So you can get a better view at it on the board. This is CN1, it's K1 relay, and TP3 is here. So we're trying the board open. What we do is check this relay and other components on the back side, see if we see anything. So what I'm doing is looking at the bottom side of the board under that relay K1, and I found R2, and there's that little surface mount resistor here, and what I'm seeing, it looks like there's a bubble right in the middle of that resistor. I'm going to put this under the microscope and see if that resistor has gone bad or if it's blowed. That resistor should be 470 ohms, so I'm going to check across it and see what we get. And I've got the probes on the resistor, and I see nothing on the meter. Okay. Okay, so I'm looking at the bottom of the board through the microscope, and that's R2, and you can see the whole center of it is blown out. I've checked this cap and this diode, which this diode is just on across the core of the relay, and I don't see any problems with those. It's just this resistor, and This goes directly to the CN1 port connector. So I'm not sure why that resistor blowed or what's caused it, but something has surely broken too, so I'm going to pop that one out and put a new 470 in place. I just want to show you this is all that is left of R2. As you can see, it is blown completely in two and it's very blackened. I'm not sure what caused it, but it surely died a horrible death. Okay, I got the board back in. I have checked. We still don't have RF power out the PA unit, but after replacing that blowed out resistor, and our spectrum analyzer is trying to work again, so we can take a test with the spectrum analyzer. And you see we have a pretty good signal coming out of the drive. It's about minus 70 dBm. Test 1, 2, and it's modulating. So it looks like everything on the TX board is now working. We just got to figure out why we don't have any RF output power. Again, like I said before, we got to go into the PA and make sure it's turning on and see if the signal is arriving there. It could be something as bad as a connector that's faulty, but we'll check that out and see. Alright, back in a bit. So I want to show you this right quick. You know, you never know what you're going to run into when you start working on a radio like this, especially when several other people have worked on it. But I pulled the filter board out, and I noticed there's a connector here that has nothing plugged into it. You can see right there. There's nothing was hooked into that connector. And of a metal tray that sits in here, and then your filter board sits on top of it. When I pulled the metal tray out and started looking, there's a connector here that's just hanging free. There it is. And I looked at the schematic, and that is supposed to be plugged into this connector, which is CN2. And I believe this carries the PTT line to the PA system. So I guess I'm going to stick this back in and test it and see what we get. It'll be interesting. Okay, we have verified we got signal coming from the TXRX unit and going into this part of the final unit. I have verified that we have single, it says PO on CN2 coming out and going down into the filter unit. And from the filter unit, this is where our antenna connectors are. So this part here concerns me as a ribbon cable in between these two units that talk to each other. So it could be that our 8 volts and 5 volts is not making it back to the final unit. So we'll have to go in and check that, take a look at that ribbon cable. That means I have to pull the filter unit back out to get a good look at that. But we know the signal is getting to the final unit. It's just not turning on and amplifying it. Okay, the radio is now completely back together. And a recap of what we've done. In our first video, we replaced this main board with the board that Grant gave us. The second video, we repaired the front panel display. And in this video, we seem to have found multiple problems. Burnt resistor, a few other things, one connector not connected, and all that's back done. So now it's time to see if we have any output power yet. Come on, get up there. Alright, I got the radio on FM, 20 meter band. We're going to key the mic. Oh, we have 100 watts. Alright, we'll switch over to AM. That's a lot of power for AM. Okay, we got AM. Switch to upper side band. Test 1 2 1 2 test audio, and we now have power on single side band. So the TS-50 is now completed and it's back working. A lot of problems in this radio, and we better to go through them and get most of them fixed. I'm probably going to need to sit down and do a alignment on the radio and check everything, and look at some more of those caps. But I believe the rest of it will be simple, just a little maintenance to do. Anyway, that'll conclude the TS-50 video. So I know one of the other ones that everyone's waiting to get back on is the TS-940, which has PLL problems and other multiple problems. And it seems every time I put the radio on the bench, something else happens and it quits on me. So as soon as we can narrow down some intermittent problems, we'll have it back on the bench and check it out. Anyway, I hope you enjoyed the video. If you did, give it a thumbs up. And remember, sometimes, like I said before, just looking around, checking different things, you'll find some problems that you wouldn't normally notice. Anyway, until next time, we'll catch you later.